Is it audible now?
Yes, sir.
Can we start? Can we go ahead?
Yes, sir.
Okay, first of
Yes,
all,
sir.
I'm
Yes,
very
sir.
sorry that today we are engaging in the evening time, but unfortunately, I have been engaged in uh, uh, some activity we have been planned actually for this corona. So we have been engaged in doing that actually in the day, that to provide some groceries and some vegetables for senior citizens, and all that we are doing it. So sorry for that, and probably from next week onwards, I think as per your timetable schedule, we will plan accordingly, right?
Okay, sir.
Okay, sir.
So today we know that from last two classes, I think we have covered turbines and pumps. Both are, one is power observing device and power consuming power producing devices that we have seen and we have discussed. And in the pumps, we have discussed about the power that is rotodynamic pump, that is centrifugal pump, and also one is on reciprocating pump we have discussed. So today it's a very interesting that is on IC engine. So today we will be discussing on IC engine. Hope you will all enjoy this session. We know that IC engines, more or less, we are very close to it actually. We normally we use it in our day-to-day. We use it for our day-to-day application, right? So in this, it's a very vast subject. Are you able to follow the slides? Are you able
Yes.
to see the slides?
Yes, sir.
Yes, fine. So we'll be discussing today with respect to IC engines as per your syllabus, that is module 3. So in this, basically, we'll be dealing with the introduction, that is what is exactly the IC engine is all about, and classification of IC engine, that we even daily basis we see many IC engine vehicles on road, but how exactly it is different from one to other, and what are the different modes of or what are the different category in which the IC engine is going to be classified. And of course, we use a different terminology for IC engines. All that we'll be discussing in detail, and also the parts which are going to be associated. The more we know that we use it to the vehicles and every day, but probably in detail we will be discussing with respect to the parts of the IC engine. And uh, according to your syllabus is concerned, there is about we use 4-stroke SI engine and 2-stroke SI engine. That is what is the difference in between, and what is exactly how exactly the 4-stroke SI engine works, and how the CA engine actually perform, and how the 2-stroke engine is different from 4-stroke engine. All that we'll discuss. Okay, so and also probably by today, I think we can be able to finish off up to 4-stroke SI engine, and then we'll close this today. So just give me 2 seconds. So if you look at the IC engine, so normally any engine, more or less, there will be a conversion of energy from one form to another form, which takes place, that we have even discussed in our most of the classes. This we have discussed, that more or less in any engine, or any, particularly when we talk about any mechanical engine or machine or any device, if you talk about in terms of mechanical, so more or less there will be some energy conversion which takes place. Right. So this is IC engine is also an engine or machine, we call it as, but broadly we say that it is a heat engine. So what exactly the heat engine is nothing but, as the name itself indicates, there is a heat. So it is an IC engine is a device or a heat engine in which transform of chemical energy into thermal energy, which is going to be taking place. So it is an engine in which the thermal energy is going to be produced by combustion of fuel, and air mixture, and in turn it is going to be converted into useful mechanical work. So this is what the broadly we define it. So any device or an engine, if it is in which it is going to convert the, or it is going to generate the thermal energy by combustion of fuel and air mixture, and in turn it is going to produce or convert that thermal energy into mechanical energy. Is it clear, friends? So it's a very simple in definition. It's very simple in definition. It's an engine or device in which the combustion of fuel takes place, in which the thermal energy is going to be produced by combustion of fuel and air mixture and produce mechanical work for useful for variety of end application. Right. So this is the definition. If you broadly classify it, the moment we say combustion of fuel, the combustion of fuel can takes place in two ways. One is by external combustion engine or by internal combustion engine. So broadly, if you think either the combustion can happen within the system or inside the system, or it can be take even external. So based on that, it is being distinguished, or it is being differentiated as external combustion engine, that is EC engine we call it as, and another one we call it as IC engine. So more in the IC engine, the combustion of the fuel and air mixture which is taking place inside the cylinder or inside the system. So that is why we call it as internal combustion engine. Whereas in external combustion engine, the combustion of fuel and air mixture which is going to take place outside the engine. So that is why we call it as external combustion engine. So for your subject is concerned, it is very ideal to start, or it's very good to start with respect to internal combustion engine, and we'll be deliberating on internal combustion engine. So if you say IC engine, again IC engine is nothing but it's a heat engine in which the thermal energy is going to be produced by the combustion of fuel and air mixture, and in turn it is going to be converted into mechanical energy. Right, friends? So this is the definition of an IC engine. If you look at the classification of point of view of the IC engine, we find a variety of number of types of IC engines we find in the outside market, and the roads are going to be experienced with different types of IC engines. So it is going to be, classified in from different aspects. So it can be one by one we will be just discussing. So anyway, it is there in the presentation. You can just go with the slides. So it is going to be classified into various aspects. It can be a number of strokes. It is very, very important in the IC engine. It is whether it's a 4-stroke engine or whether it is a 2-stroke engine. So 4-stroke engine, one best example for 4-stroke engine is for example, we take Hero Honda, all these vehicles which all falls under 4-stroke SI engine. And also we very popular bike, that is Yamaha. Yamaha is an example or best suited for 2-stroke SI engine. It's a 2-stroke engine. So what exactly the 4-stroke and 2-stroke engine, that we'll discuss in the forthcoming slides. Broadly, according to the number of strokes, it is classified as a 4-stroke and 2-stroke engine, and also it is going to be classified based on the type of fuel which we are going to use it. As we know that we use petrol engine, we use diesel engine, we also use LPG, that is liquefied petroleum gases, we use biofuels. There are particularly the BMTC buses which are being operated with biofuels with certain proportion. So it is also going to be classified based on the type of fuel which we use. At the same time, based on the method in which the ignition which is going to be taking place, based on that also we classify whether it is a spark ignition engine. We know that more or less we use spark ignition engines or whether the method of ignition is going to be compression ignition engine. So based on this ignition system, we classify into SI and CI engine. SI in the sense it is going to be spark ignition engine. If it is a CI engine, then it is going to be compression ignition engine. So compression ignition engine, if you take any car or any diesel vehicles, which is going to be come under CI engine. So why it is CI engine? Because why it is CI engine? It is connected to internet. Why we call it as CI engine? Because we use compression ignition method in the diesel engine. So that's why all diesel vehicles which is going to be falls under CI engine, whereas all the petrol vehicles which is going to be operated under SI engine, because it is a spark ignition engine. The spark which is going to be produced with the help of two different electrode which is going to be provided in the spark plug. So that is why SI engine and CI engine we call it as. So SI engine in the engine in the sense it is a spark ignition engine. All diesel vehicles, it is going to be CI engine, that is compression ignition engine, right? But don't get confused with IC engine. IC engine is internal combustion engine. So under that we classify as SI and CI engine, as we discussed. And also it is going to be classified under based on the cycle of combustion. As we know that every operation, every mechanical operation, it is going to be assumed to be operate in a thermodynamic cycle that we have discussed in the thermals while discussing on thermodynamics. So based on the cycle of operation, we also classify this IC engine, whether it is a auto. Based on that, we classify it as auto cycle engine, diesel cycle engine, and also dual cycle engine. So what exactly the auto cycle engine, what exactly diesel cycle engine, and what about the dual combustion cycle engine, that meanwhile we'll be discussing in the further coming slides. So based on the cycle of combustion, auto cycle, diesel cycle, and dual combustion cycle. So these are the three which is going to be under the cycle of combustion. And also it is depends on the number of cylinders, whether it is a single cylinder, whether it is a multi-cylinder. So based on that, so if you go with heavy vehicles, it is going to be, for example, trucks and all that, whatever we use it. So that is all going to be multi-cylinders, whereas our petrol vehicles, it is more or less, it is going to be single cylinder. Also, by position of the engine, also by position of the cylinder, also we classify whether it is a horizontally engine. Are you able to follow?
Yes, sir.
Yeah. So based on the position of the cylinder, whether it is horizontally mounted, if it is horizontally mounted, then we call it as horizontal engine. If it is vertical engine, we call it as vertically engine. If it is going to be inline, then if it is inlinely mounted, we call it as inline engine. And also there are radial engine, V-type engine, right? So these are the few types of engines which is going to be particularly based on the position of the cylinder, we call it as. And also very importantly, we also classify the IC engine based on the cooling mechanism. So whether it is a liquid cooling. So air cooling, then we call it as a air cooled engine. If it is a liquid cooling, then we call it as a liquid cooling engines. So what about our vehicles by SI? What about our two-wheelers? All that, whether it is a air cooling or liquid cooling?
Liquid cooling.
Liquid cooling. So based on the cooling mechanism, we classify as air cooled engines, and even the water cooled engines are also there, right? So according to the users, based on the users, whether it is a for example, some of the vehicles we use it for our to move from one place to other place, that is automobile engine, which also come under. So there are also we use stationary engine. Even there are some engines which are going to be used to produce even power. So there are such even plants are going to be exist. So that is all come under stationary engine, marine engine, aircraft engine. So this is, so these are the different types of categories in which the IC engine is being classified, right, friends? So this is with respect to classification. Now if you look at the meanwhile, whatever we have discussed, it is there in the presentation or slides. So we'll move with the next one. So if you look at the a complete an IC engine, probably we may see the outer surface of the engine, but if you look at the illustration which is given in the slide, better you can understand the terms or different components which are being associated with the engine. We can be able to see it, right? So from so it is better to start from the top. I'll be just explaining you from the top what are the components which are being associated. So the first one is going to be the very major, it's the heart of the engine, we call it as, it's the cylinder. So whatever the cylinder, it is in the middle, whatever it is there in this, in the center, this part, or it's a cylindrical vessel, we call it as, it is mainly made with cast iron or aluminum, not aluminum, it is going to be made with cast iron, particularly to withstand high amount of temperature and pressure which is going to be generated because of the combustion of the fuel and air mixture which is going to be produced, right friends? So here normally the fuel and air mixture which is going to be drawn inside. So one is to, it is hold the fuel and air mixture, at the same time to takes place the combustion. So all that it is going to be supporting. So this is called something called cylinder. So in this, the combustion of the fuel which is going to be taking place, and that is why, that is the reason we are calling it as IC engine, because the combustion of the fuel which is taking place inside the cylinder, it is taking place. So that is why we are calling it as IC engine, and that which is going to be taking place within the cylinder itself, right friends? So one more, that is called cylinder head. So normally this cylinder head, this is going to be a separate individual part. The exactly just above this, whatever you are finding, it is going to be called as cylinder head. The major reason being, using cylinder head is to incorporate the valves. That is the left one, what we can find out using some spring mechanism. Even in the right side you find, and also in the middle we can be able to find out this spark plug or fuel injector based on the whether it is a SI engine or CI engine. So normally the cylinder head, which is going to be a separate component, as you can see here, a just small line. So this differs from the cylinder and the cylinder head. So in this cylinder head, to mount the valves and the fuel injector or spark plug based on the application, right friends? So these devices, so normally we use it, it is not going to be an internal part of the engine, it's a separate part, because most of the time it is easy to maintain, or it is easy to use it and remove as and when required. So in order to do that, it is going to be connected to a cylinder with a tight sealing, so that it should not get any leakage or any air trap in between, or it should any combustion fuel should not come out. So but the cylinder head is also made up with a cast iron again. So in order to withstand the high temperature and pressure due to combustion of the fuel air mixture, combustion of the fuel. So this is going to be and also a very one more important part is the piston. So what you can find out within the cylinder itself, you are finding 5 to 6 horizontal line. So that is actually in the front view, it is seems to be as a line, but it is going to be having a circumferential area. It's a cylindrical object actually. So in this piston is to this piston, the forward and the movement of the piston within the cylinder, due to which what will happen, it will induct the fuel air mixture, and also the force which is going to be generated on this piston, and the movement of the piston which is going to be taking place because of this freely movable piston with a very close tightening between the cylinder surface and the piston surface. So this is also very important device which we are using, that is something called piston. So this piston, due to the movement of the piston, the force which is going to be liberated because of the combustion of the fuel. And this piston, which is also what you can see here, there are two lines, there are 4 lines. The top 2 lines which indicates as piston rings. The second one also, so normally if you look at any piston, it will have 2 piston rings. So what exactly the piston rings is doing is, the piston rings are going to be a very it is made up with a steel structure, and it is going to be so that elastic property can be enhanced even at very high temperature and pressure. so that there are two types of such elastic rings or piston rings we use it. One to what will happen, one ring it is going to uh, what will happen, the oil which we separately use it for cooling application, right? So it is across the cylinder surface, the oil which is going to be oil is going to be spreaded across to cool that cylinder against to the high temperature. So that after once it is going to be cooled, the oil after cooling it is going to be supplied back to the oil chamber. That is happens because of this piston rings. At the same time, it is very sophisticated design, because it has to be placed over the piston. At the same time, it should make a very good contact with the cylinder. So any further change in position or anything, so it may it may uh, uh, it may creates a problem, because the fuel and air mixture which may comes out from the cylinder, there will be chances. So very good piston rings which is supposed to be used, that is made up with steels. So one more ring that is going to be used. So normally what happens in the combustion, after the combustion is produced, a certain quantity of exhaust gas, it is always it is going to, it will try to exit from the chamber because of the variation in the properties. So there may be a chances of the exhaust gas, or sorry, there may be some gas which is inside the combustion may come into the come into to the lower portions of the cylinder. Lower portion in the sense, there is something we call it as a crankcase. At the bottom of the portions of the engine, we call it as a crankcase. So some portions of the gas may always try to escape from the cylinder, and there may be a chance of directing into crankcase. To avoid such, or to prevent gas liberating or taking out or moving out from the cylinder, one ring which is going to be acting. So there are two types of ring which we use. One is oil ring, the another one is compression ring. Is it clear, friends? So this is with respect to piston ring. Also we use different types of valve. One is inlet valve. The left side we call it as an inlet valve. It is going to be nowadays the valves are we know that earlier the IC engines are going to be completely mechanical, but nowadays the IC engine becomes very sophisticated in nature, and more or less there is a ECU systems has come, electronically controlled units have come. So valves and everything, it is going to be completely computerably programmable, everything. But earlier one, it was normally it is going to be operated with the help of camshaft. I think the cam in the moment you say cam, I think you have seen in the glass wiper, that glass wiper which is going to be the power, I mean to say the power which is going to be produced in the engine, it is also going to be used in variety of application within the vehicle itself. Partly it is going to be used for glass windows, for wiper. So it's variety of places we use it within the vehicle itself. So earlier the valves are being which is going to be completely operated by connecting to a cams mechanism over the crankshaft, over the camshaft. But today it is being everything, it is going to be electronically controlled. But however, ideally there are going to be used two types of valves. One in the left side we use it, we call it as an inlet valve, and in the right side one we are going to call it as exit valve, right? So inlet valve, in the inlet valve, when it opens the inlet valve, so normally what will happen, the fuel and air which is going to be inducted into the cylinder by remains closing the close valve or exhaust valve. Similarly, once once it completes the cycle, the inlet valve is going to be closed, and the exhaust gases which is going to be liberated to the atmosphere with the help of exhaust uh, exit valve. Is it clear, friends? So this is going to be inlet valve and exhaust valve. Is it clear, friends? So there are two types of valve we use it. And also there is a crankshaft. Crankshaft is at lower portions of the crankshaft, what you are finding is a small circular one. That is something we call it as a crankshaft. We know that because of the combustion of the fuel, the pistons, it is forced to move from top to bottom and bottom to top. So this is a this is what you can say. It is a reciprocating motion of the piston and cylinder, reciprocating motion of the piston within the cylinder, which is going to be uh, converted into rotary motion. So this rotary motion, from reciprocating to rotary motion, which is going to be taking place with the help of crankshaft. The crankshaft is going to be it's a cylindrical shaft. This cylindrical shaft